This is the second part of this of the video. The first part I talked about the pyrimidine biosynthesis and I described the pathway. Now I'm going to be starting with purine biosynthesis. So let's go back to the board.
Yeah, hello everyone. My name is Famous. Then, from our previous video, I talked about the novo pyrimidine biosynthesis and pathways. So, when you discuss the novo pyrimidine biosynthesis without discussing purine biosynthesis, it's not complete because both of them go hand in hand. So today our topic it's de novo purine biosynthesis and the purine salvage pathways. So we know that the purine biosynthesis it begins with the reaction of ribose 5 phosphate, conversion of ribose 5 phosphate to PROPP, conversion of ribose 5 phosphate to PROPP by PROPP synthetase, and because PROPP is actually the active form of ribose 5 phosphate. Now, ribose 5 phosphate it comes from the hexose monos phosphate shunt. That's where it comes from. Then, from when it's being converted to PROPP, then PROPP is being converted to IMP. Then IMP can diverge to now IMP we now diverge to two tracks, which is AMP and GMP. So I'm going to use the board to do the illustration. So the beginning of the reaction it starts with ribose 5 phosphate, and as I said earlier, ribose 5 phosphate it comes from hexose monosphosphate shunt, which is also known as the pentose phosphate pathways. So ribose 5 phosphate is being converted to phosphoribose pyrophosphate. Phosphoribose pyrophosphate is this conversion is being assisted by PROPP synthetase. Then PROPP is being converted to IMP. Now I talked about PROPP is being converted to IMP, but in between this PROPP and IMP, there's also some certain intermediate pathways. There are also some intermediate elements there. So PRPP is actually converted to 5-phosphoribosylamine. So this 5-phosphoribosylamine, this conversion is being assisted by PRPP aminotransferase. Then this 5-phosphoribosylamine is directly converted to IMP. Now, between this PRPP and 5-phosphoribosylamine, glutamine comes into. Now, for the purine biosynthesis, glutamate, aspartate, and tetrahydrofolate is actually needed for this reaction to occur, which is glutamine, glutamate. Sorry, excuse me. Glutamate, aspartate, and tetrahydrofolate is needed for this reaction. So from there it proceeds to inosine monophosphate. So from inosine monophosphate, IMP is being converted to adenosine monophosphate through the enzyme adeninosuccinate synthase. IMP converted to AMP through the enzyme adeninosuccinate synthase. The IMP can also be converted to GMP. But in between the IMP and GMP, we can find xanthosine monophosphate. So IMP is converted to xanthosine monophosphate, then xanthosine monophosphate is being converted to GMP. Now, this PROPP synthetase is actually the regulatory enzyme for this purine biosynthesis. Because why we call it the regulatory enzyme, because without this PRPP synthetase, this reaction cannot occur actually. So one of the hindrances of this PRPP synthetase is high level of phosphate and high level of ADP. Now what does it mean? if there's high level of phosphate and ADP, means there is not enough energy to power the system. So high level of phosphate and high level of ADP will shut this system down. So it's not going to continue. These PRPP will not be converted. So also this high level of AMP and high level of GMP can also shut off this PRPP amidotransferase. So the conversion of PRPP to 5-phosphoribosylate will be hindered, which is being catalyzed by PRPP amidotransferase, can be hindered if there is high level of AMP and GMP. So that's for this. Then also for the conversion of IMP to AMP. Now, for this reaction, if there is high level, like as I said, AMP and GMP means there is high level of AMP and high level of GMP. You know the way the system works, it's because of our system homeostasis. So what the system does is, if there is an excess amount of a particular element, the system has a way of shutting down itself. So it means that if there's high level of GMP, means okay, GMP it's okay, so that there won't be some mutation. To avoid mutation, if there's high level of GMP or there's high level of AMP, the system is going to say, okay, now we're done, can we move on? So what happens if there's high level of AMP and high level of GMP? The system shut down. Now, if there's both high level of AMP and GMP, the system completely shut down. But if there's high level of just AMP, the system partially shut down. But if there's just, and also conversely, if there's just high level of GMP, the system partially shut down. But if both are both high in the system, it's complete shutdown. So now for this this PRPP, what actually now this the conversion of PRPP to also IMP is being hindered by two drugs, 6-mercaptopurines, and azathioprine. So two drugs that can hinder the conversion of PRPP. In fact, two drugs that will stop this pathway to continue, which is 6-mercaptopurine and azathioprine. Now, for this other part, then there is two drugs that can hinder the conversion of IMP to GMP, which is mycophenolate and ribavirin. We should take note of this. These are key. These are high yield questions. The drugs that will stop the purine pathway completely. It stops it. That is, this first step stops. So the regulatory it stops the complete continuation of this enzyme, 6-mercaptopurines and azathioprine. Then for this IMP to GMP is mycophenolate and ribavirin. So from there, this is the pathway for the purine synthesis. Then this is the novo. This is the salvage pathway. Now, for this salvage pathway, definitely it begins just with ribose 5-phosphate, which comes from the hexose monophosphate shunt. So ribose 5-phosphate, which is produced from the hexose monophosphate shunt, is being converted to IMP, just like what I said here. It's being converted to IMP by PRPP synthetase. Then this IMP can be converted to either GMP or AMP, just like what I said here. So IMP will be converted to, and this it's both ways. It can be converted to either GMP or AMP. Now directly GMP will be converted to this nucleotide. This nucleotide. So yeah, GMP will be converted to this nucleotide. Then this nucleotide will be converted to this nucleoside. So which is a GMP to guanosine, then guanosine to guanine. Then same with this side, this other way, IMP will be converted to inosine. Then inosine will be converted to hypoxanthine. Then hypoxanthine will be converted to xanthine. Then for AMP will be converted to adenosine. The adenosine, it's going to be converted to inosine. So that's how it operates. Then from here, xanthine, uric acid, and urine. So another thing we should also take note of is guanine can be converted to GMP through the help of PRPP and this enzyme hypoguanine phosphoribosyltransferase transferase. So guanine converted to GMP through the action of PRPP and hypoxanthine guanine phosphoribosyltransferase transferase. Then also hypoxanthine can be converted to IMP through this same enzyme PRP through PRPP and hypoxanthine phosphoribosyltransferase transferase. Then this xanthine oxidase, it helps. It's a proenzyme that helps in the continuation of this reaction. So it found in between hypoxanthine and xanthine here, and xanthine and uric acid here. So now I'll talk about this. Now, aspirin here. Aspirin. Let's start with probenicide. Probenicide, it's a proenzyme that helps to it makes this reaction continues. It helps to make this reaction continuous. Why aspirin? Aspirin hinders this reaction. Aspirin hinders the conversion of uric acid to urine. So why rasburicase also it helps in the conversion of uric acid to urine. Now, for this salvage pathway, there are two major diseases we shouldn't forget, which is okay. Before I come, I will talk about this adenosine deaminase. Adenosine deaminase is the enzyme that converts AMP to IMP. Adenosine deaminase enzyme, it converts AMP to IMP. So if there's a deficiency in adenosine deaminase enzyme, which leads to adenosine deaminase deficiency, it can cause disease there. So which is the cause of autosomal seed. So this deficiency in adenosine deaminase enzyme, which is adenosine deaminase disease, is the major causes of autosomal skid or seed. Then for lectinihans sidon, which is an X-linked recessive, which is X-linked recessive, is a result of a complete absence of this hypoxanthine guanine phosphoribosyltransferase transferase. So if there is complete absence, of this enzyme, what happens is this. Sorry, excuse me. If there's complete absence of this enzyme, what happens is this: is that there will be accumulation of hypoxanthine, which could lead to hyperuricemia. Now, because it, of course, from what I said earlier, it is this hypoxanthine guanine phosphoribosyltransferase transferase that converts hypoxanthine to IMP. So if this enzyme is not available, there will be accumulation of this particular enzyme, and definitely this once there's accumulation, then there will be continuation. Then this pathway will not, this short pathway will not, this intermediate alcohol will not be active. So there will be excess production of hypoxanthine. That means which will lead to the xanthine oxidase to continually produce hyperuria, which we call hyperuricemia. Now, for the treatment of this Lechlinian syndrome, what is being targeted is this part, the conversion of hypoxanthine to xanthine. So what happened is these drugs, allopurinol and febuxostat, we hinder or slow down this reaction. So if it's being hindered or slowed down, so the conversion, so that uricemia, so that there will be, so that hyperness in the system will be reduced. So allopurinol and febuxostat, it's what is the drug that is needed for Lesch-Nyhan syndrome. And we know Lesch-Nyhan syndrome, most of its clinical presentation are dystonia. Use this one as dystonia. You know, the patient normally have dystonia. Then, as I said, this is hyperuricemia. Then the patient also suffer from gout. Then the patient also suffer from excessive anger. The patient normally suffer from excessive anger. So this is then the mental retardation. So this is how to remember the clinical features, the clinical presentation of Lesch-Nyhan syndrome. So that in a question, once we begin to see these features, we know it's Lesch-Nyhan. So hyperuricemia, gout, excessive anger, which is, let's say, pissed off. I use this as being pissed off. This is gout. This is hyperuricemia, pissed off. Then this is retardation, which is a low mental IQ. Then this is dystonia. Dystonia, of course, is uncontrolled twitching of your muscle. So that is how to remember the clinical presentation of this Lesch-Nyhan syndrome. So I hope I've been able to explain this. These two, the salvage pathway itself and the purine biosynthesis pathway. So more videos will be coming your way. So you just like my channel, you encourage by leaving a comment, and I'll see you next time. Thank you.